For SQL injection, the BrickSwap application was used to simulate a vulnerable login page of ABC Bank Company. At first, enter random login credentials to test how the application processes the username and password. It displays wrong username or password. At the bottom, the SQL query process was displayed. We will change the logic of the SQL query. So that the condition will become true without providing the correct password. Then we will try again. It will display the successful login message with the modified SQL query.
Hi Miss, my name is Loh Chjun Kitt, and now I'm going to present use SMTP user enumeration using Metasploit. And now I'm going to check the IP address of the working machine. And this here you can see that 192.168.1.123. And now I'm going to currently enough the attacker machine to see the NNet 192.168.1.123. That's it. Here we going to scan the available port. Here we can see the SMTP open slot using MSF console. The root the MSF console. Click simple mail transfer protocol. And here we can see the available scanner. And now I'm going to use this 49. Use 49 and show the options to see the R host is missing. So I set the R host to the victim machine and show options. And we can see we can set already. And here we just set the user bound into it. The user bound is all the username, the dictionary username. So I run. Now we can see the user have been found. Then we go to the telnet 192.1.7 for the port 25. So we go to verify the pin. So pin is pin. It's possible at the victim machine. So verify. So one more FTP. Also is possible. And now I'm going to present the remote access testing using reverse shell. And here I'm going to the Kali Linux and set up the NC NLVP, set up the netcat to initiate the connection. The port 5555 is the port. And then we go into the victim machine. The victim machine maybe will install unintentionally install the wireless that have the command like cat 192.168.1.122. This is the attacker machine. And then the port is 5555. And then and green batch. So when it unintentionally execute the code, then the attacker machine will listen. And the attacker machine can know the hardware of the victim machine, can know what it has got the insights, and then can see the vulnerable to go inside to see, and then it also can IP address, can see the victim IP address.
The cross-site scripting test is conducted using the block function in the test environment. A normal block entry is submitted to understand how it processes and stores user input. The message appeared in the current block entries. Then the input field is tested for store cross-site scripting. JavaScript referencing document.cookie was supplied through the block input field in the control test environment. After submitted, the browser displays cookie map information in an alert box. This demonstrates that the application did not properly prevent as the supplied JavaScript is still being executed by the browser. The block entry of the JavaScript payload is still stored. It can be processed and executed again when the affected block page is viewed. This shows the store cross-site scripting vulnerability in the test application.
Now I'm going to demo the ICMP ping attack. And now I'm going to see the IP address of the victim machine is 192.168.1.117. And then go to see the statistic. Is all 0. And now I'm going to test the send 4 packet to the victim machine and see. So I have got the 4 ICMP packet received. And now I'm going to do the demo the attack. So is sudo string 3 ICMP blood random source 192.168.1.1.117. So starting the attack. And here in the victim machine, I'm going to run the sudo tcp dump ICMP. So see the ICMP is all a lot of the packet sent come into it. So now I'm going to stop the attack, stop it, and then here I also stop it. So I'm going to see the statistic of the ICMP. So the statistic is a lot of about 63,000 of the ICMP message received. Now I'm going to demo a host-based firewall for security countermeasure. Now I'm going to show the default firewall configuration. So this is the default firewall configuration. Now I'm going to show the network statistic. So it's all 0, and now I'm going to add a new policy to my firewall. So and now I'm going to show this one. So I already add 2 policy into my firewall. So here, so now I'm going to launch the attack to see whether the firewall can block my packet, to deny my packet. So now I'm going to see the TCP dump ICMP. So a lot of the packet is come inside. So now I'm going to stop the attack. Stop the attack. Stop the attack, and then I'm going to see the analytic. It does 321 ICMP message received, and I see the tables. My table is just 321 packet accept is matched, yeah, and then 62,000 packet is being blocked.
Demo the phishing using social engineering toolkit on Kali Linux. Select the social engineering attacks, the website attack vectors, credential harvester attack method. Choose the web template. The postback address is configured to represent the Kali Linux machine used in the control test environment. Choose Google. After the test environment is prepared, you create a simulated password reset email. The email contains a phishing link which is click here to reset your password and will link it back to the Kali Linux machine using the postback address. When user receive email and click, it will be directed to an imitation sign-in page. After filling in the credentials, the info entered in the test environment will be received by the social engineering toolkit in Kali Linux. the recorded email and also the password. This shows that the submitted email and password field is recorded and can be used to log in into the ABC Bank Company Google account. This shows that the sensitive login information is already disclosed. The cross-site scripting test is conducted using the block function in the test environment. A normal block entry is submitted to understand how it processes and stores user input. The message appeared in the current block entries. Then the input field is tested for store cross-site scripting. JavaScript referencing document.cookie was supplied through the block input field in the control test environment. After submitted, the browser displays cookie map information in an alert box. This demonstrates that the application did not properly prevent as the supplied JavaScript is still being executed by the browser. The block entry of the JavaScript payload is still stored. It can be processed and executed again when the affected block page is viewed. This shows the store cross-site scripting vulnerability in the test application.
For the vulnerability of the weak password, the threat will be the password can easily to get exploited. For the attacker will use IPA to check the local network of the PC1 that is assigned, and then use mapping to scan the entire of the 10.1.136.0 of the subnet. And then for the result, we found out that the victim PC is assigned as 10.1.136.32. On the UMP map to scan the IP address. And from the result, shown that SSH server is active in the victim server. After that, the attacker will use Hydra to try to export the victim PC. And the Hydra has successfully cracked out the password of the victim PC, which is password. Now we can try to connect to the victim PC using the password. Now the attacker has successfully connected and logged into the victim PC, and the attacker has get the full access of the victim PC. It can using LSLA to check out the directory and the files inside the victim PC system. It can also add something inside or delete the information. Like for example, using echo to add a DSP file. Now that the DSP have been successfully added, we can also remove the DSP file. The file have been removed. That's all. Now I will talk about the countermeasure of the vulnerability of the weak password by using the exit control and education. The VDPC can change the password to a more complex password. After changing to the more complex password, when the attacker try to use Hydra to export the password, it will become harder. The time will increases and hard to crack the password because it is now a complex password. Next, the company can also change the configuration of the AHAsh server by active the education. Finding the public key education and remove the hashtag to active the parameter. And found the password education, remove the hashtag to active the parameter and change the default setting yes to no. After that, save the complication. And then restart the SSH server. After restarting, when the attacker tries to use Hydra to crack again the password, it will find out that the permission will be denied. Because that the SSH server now not support for the password education. And if the attacker try to connect to the SSH server, the permission will be denied. That's all.
My name is Yeoh Khang, and in my demonstration part, I will present about ARP spoofing along with its countermeasure, static ARP entry. First, let's briefly explain the whole process. We will have a laptop with Kali Linux OS as the attacker and a laptop with Windows OS to simulate a consumer as the victim. Both devices are connected to the same Wi-Fi. On Kali, a software named EtherCap will primarily be used for spoofing, and Wireshark will be used to show the spoofing is success and traffic from victim is routed to attacker. To start the penetration testing, we need to know the target's local IP. Since I have access to the terminal of target device, I know the IP is 192.168.0.114. In case we don't have access, we can use NetDiscover in attempt to identify the IP. Before we start the spoofing, here is the original gateway MAC address presented in victim terminal with command ARP space -A. It is something start with 58. The first step is to use this command. This enables attacker device to forward package from victim to original gateway and vice versa. So during the spoofing, the victim still has narrow access and likely will notice that he is unsafe. After that, start EtherCap. Make sure the correct interface is selected, then press apply. Now press host list and then scan for host. Wait for a while. This is the gateway IP and this is the victim IP. Add victim IP to target 1 and gateway IP to target 2. After that, click on the globe icon, choose ARP poisoning and press OK. From below, we can know that the ARP spoofing is started. Now we jump to the victim device. We run the command ARP-A and we can see that the gateway MAC is altered. Using Wireshark, we can start observing the traffic from 114 that was not visible before. However, due to modern settings, we can't directly read them for now and might need more advanced steps to decrypt them. Now we talk about the countermeasure. The simplest but not the safest method is using static ARP entry. This method fixes the gateway MAC from a local, but we must know that MAC address can be spoofed too. Additional security measures such as DHCP snooping require access to switch and router, which I currently don't have, and regretfully I can't showcase in this video. That's all for my part. Thank you for watching.